Okay, I'm going to be the panel moderator for this session called Open System Firmware Enhancement Opportunities for Heterogeneous Computing. So today on the panel guest, we have Nill from ByteDance as a firmware architect. We also have John Masters, ARM server architect at Google. Nachimuthu from Intel as a senior principal engineer. And then also Vishal Soni, principal software engineer from Microsoft. So today we're going to show you a few slides, and then we basically go into the Q&A sessions. Oh, the lights are so bright. Just a little bit of a history of our program. In 2018, OSF, the Open System Firmware, became the incubation project in OCP. And at the time, we have representatives from Google and Microsoft running the group as a co-lead. And then in 2020, it finally graduated from the incubation project into an official project in OCP. And actually, at that time, Google was leading the project with 2 representatives. And in 2021, I think Intel and Google joined the effort to lead the group, and Google also offered another representative to be on the incubation committee of OCP. And then in 22, we continued to have Intel and then Meta also join as the lead for this project. And I became the representatives onto the incubation committee. And then we also have changes along the way in the last couple of years. We have now Sammy and Nill leading the project, and I continue to serve on the incubation committee. I think this year, the OCP has changed the name for the incubation committee to be the steering committee. So I continue to serve there representing this project. So today we're going to be talking about possibilities of more work streams on heterogeneous computing moving forward in this project. So we will have these guests helping us to answer some of the questions from me and from you guys in terms of what they think this group could continue to lead in this industry. So I guess this term heterogeneous computing, maybe people have different interpretations of the word. So we try to kind of settle down on what we are talking about really. So here, when we are talking about compute, there could be different variations, little, big, little cores, which is now not only in the ARM architecture, but also on the x86 side as well. We also talk about GPUs and DPUs and IPUs, accelerators, all kinds of possibilities, right? And so with that, you would have the non-uniform memory issues, the bandwidth or latency. We introduced the technology CXL to support a lot of the memory pooling, memory support in addition to the DDR, and then GPU certainly has its own local memory as well. And we also touched into the security side of encryption and so on. So there are a lot of variances in interface properties for security firmware update, power, performance, RAS, telemetry. I think there has been a lot of sessions at this OCP talking about all these things, manageability, what have you. Let's see. Okay, so with that, I actually have some of the questions to help kick off the conversations with the panels. And then we just prepare for questions in your mind. And I think after the first question I raised to them, I'll be asking you guys to raise questions to our guests. So the first question I have is, how is the heterogeneous compute firmware stack different from the normal stack for boot and runtime?
Okay, thank you. So in my opinion, so right now in this event, I was impressed. We talk a lot about the AI request on the computing, on networking, memory kind of things. So how can the firmware fix some gaps or provide some help on this request? So in my opinion, firmware did two things. One is for system initial. Another one is for the runtime management. So in my opinion, the phone, on the boot time, maybe no matter the application processor or management processor, we can do all the for the system initial. For the runtime, I like the application processor focus on the business. Then we can do design some management processors to focus on the management. Then, yeah, that's my general idea. Thank you.
I think that's a good comment about machine learning, right? Like I was wondering who was going to say machine learning or AI first. So as a person who works at Google, I should definitely say machine learning and generative AI. So I've said that. But joking aside, I think there are two things missing on this diagram that Dong had. I think the diagram's great, but I think let's put confidential compute in there and also machine learning as two trends that need to intersect, right? So, what does that mean? Well, that means that if you look at the OSF project as it started out, as it initiated, it was very much focused on the host system, right? And the idea that you attach, endpoints to it, traditional PCI devices, something like this, right? I think in these new emerging models, you have more sophisticated endpoints. So you could have, CXL.mem, memory pools, sure, but you're going to see more and more sophisticated devices attached. So I think eventually over time, that sort of trusted compute base, right? If I bring in the confidential compute piece for a second, the piece that you need to trust in the system is going to expand, and it's probably going to expand beyond the host. So even though the host is today the focus, I think that heterogeneous compute changes the dynamic and starts to bring in these other components in the system because they become part of the TCB, but also because if you want to have them work together, right, you're introducing a lot more complexity.
Thank you.
Hello. You want to use this one?
Hello? Yeah, I think it's done. Yeah, I think we are already, if you look at systems today, we already handle a lot of things, right? You have a CXL memory and big core, small core we are handling. I think the question basically is, this additional things keeps getting added, right? Do we need to look at as a heterogeneous computing and see hey, what is that, if you look at OSF, we are really focusing on BIOS. But it's a system firmware. Supposed to be looking at just not BIOS, so you should be looking at BNC or all the CXL firmware, all the stack goes along with it as a firmware subsystem, right? That is one. And also, I think I didn't put anything on the software stack. I think I saw the AMA presentation. There is a lot of different core boot, U boot, all this Linux boot, EDK2 boot, all these things are going on, right? If you marry all these things with this additional complexity, it becomes a lot more things happening in the ecosystem. Question is, do we need to have a focused session and look at it and decide what we want to do? That is the basic question. I don't have an answer. I'm kind of looking for a community to make a decision here.
Thanks, Sammy. Right, so as Nill, John, and Sammy have chatted through, right, so from the system perspective, right, some of the renditions of this system still exist, and more complex systems are evolving. So the main thing is going to be how do we view the systems? What is the firmware? Transparency is getting more and more important in the firmware space. How do we manage the systems at scale? Specifically in data center environments, those are going to be more critical. And now the things like errors, RAS, they become more prominent in terms of how do we rationalize the whole story, and what are the in terms of when something happens, how do we manage things. So from that perspective, I think it's a new space, and we have to kind of think through what are the standards we are looking for. Standardization is going to be key where possible.
Can I add something to what Vishal was saying there, I think just, the RAS comment is a very, very good one, isn't it? Right? Like the blast radius becomes so much bigger. Yeah.
Yeah, okay, so let's see if we can have questions from the audience. We have the guests here. It's a wonderful opportunity to ask for their opinions of anything on your mind related to open system firmware or anything that this group should cover, right? So we have microphones on the side, on both sides. So yeah, just identify yourself and ask a question.
Hi, I'm Simon Glass. I work in open firmware. I wonder about the on-chip firmware and all these little things. Are you pushing for it to be open source? And I'm thinking of things like on-chip DSPs, accelerators, and PMIX and all these kind of things. Is that part of your remit?
Yeah, so anything firmware, right? That's why if you look at the starter itself, the system firmware. So you need to comprehend everything goes into the system, right? That is part of the charter. I think the question is, what we really want to as a OSF, we need to make a call and make a decision. Do we want to include the on-chip firmware, and what is that open source means? Is it a binary release, or is it an open release? Or even if you look at CXL devices, PCIe devices, or anything goes along with it, right? Even drivers, even OS drivers, even though there's a firmware, I mean, somebody has to use it, right? Whether it's used during boot or it's used during runtime, that I think need to have a conversation. And even if you look at all the updates, like NVMe has its own interface, CXL has its own interface, PCIe does not have any interface for update. It's all proprietary mechanism, right? I think that is it is included, but you need to decide what you want to do.
Yeah, if it's all right, I would add, I think coming back to the comment I was making a little bit earlier about trusted computing and confidential compute, right? I think one of the challenges we're going to have in the next few years is we want to build systems that can provide a confidential computing experience across different architectures. And if you say, trust me, right, that's great. But a lot of times people say, okay, I trust you, but I'd like to verify that. And so I think one of the lenses for the on-chip components is going to be, is that part of the TCB? And I think if it is part of the TCB, there will be tremendous industry incentive to look at opening up additional components. But I would caution that even though I'm personally a huge fan of open source and opening everything, the open in open system firmware, right? It's not open source firmware, it's open system firmware. So the point is, there are ideals like open sourcing all the things, but I think what you can do is you can apply the lens of kind of the business reality, and you can say that there are certain kind of forces at play in the industry, like confidential compute, where there is an incentive to open these pieces. And so let's capitalize on that rather than trying to open everything immediately.
So basically you're saying define the interfaces, make sure all the firmware that you're updating has a secure interface and you can attest it and everything is available, then figure out whether really need to be open outside, right? Okay, got it, thanks.
No? Vishal? No?
I'm good.
All right.
Let's see, any more questions from the audience?
There are 4 bright lights right here, and for those of you who are Star Trek fans, I'm just picturing the scene where he's yelling, "There are 4 lights! We can't see any of you."
Don't be shy. Yeah, come to the microphone and ask anything on your mind related to this subject.
Or even if you have comments that you want to say, like, what do you want to?
Otherwise, Dong's doing stand-up comedy.
Yeah, otherwise I have some more questions. So let's fill in one as you guys think about it. So how are the firmware updates to the heterogeneous systems handled? Single image, multiple images? Any ideas, opinions?
Okay, So more to the heterogeneous computer systems, more complex systems. So we have the CXL device, we have the GPU device, we have a memory pool, maybe connect to some memory pool server systems. We have HBM, we have NIC card. So it's very complex systems. So we need to manage every device. We need to interaction with every device. So in my opinion, you should define the dedicated interface with each device. Currently, as I know, so even from the same vendor, so some GPU card or NIC card, they have different auto-band device. It's really hard to do the management. So in my opinion, no matter between the firmware to the OS or the firmware between each firmware or in-band, out-band, so we should define the interface from each other. The interface may be for ROS, for telemetry, for DVFS, for server management. Yeah, that's for the assist management. Yeah, we should work on this interface. Yeah, that's my idea.
I think if you look at today, if you BIOS, it's a big component, more booting the system. And you have each vendor has its own processor, microcode or EC or firmware, like you have a processor firmware. Again, you can combine it in one and you can build a free, or you can put a NIC on your board and you can have that NIC takes that image from the free. That is all kind of happening, right? But if you look at all the devices that gets added on, right, it's all have an independent firmware. It's not like separate things. And again, if you are talking about runtime, I think cloud guys are asking, hey, I don't want to shut down my system. Can you update everything while the system is running, right? Then it becomes complex. You need to go and ask every vendor, hey, even CXL defines a runtime update, but the vendor is up to them whether to provide it or not, right? Even NVMe defines, it's up to them. Even if you look at BIOS, what you can update during runtime, it's not kind of fully clearly defined, right? I think there's a work can be done. Again, we need to put a requirements. What is the real requirement that you want to go after? And also multiple vendor has a multiple, requirements, right? Not everybody wants runtime update. There are vendors happy with booting on once and resetting the system whenever it's needed. So it's all over the place. That's what I see it.
Yes, so like, multiple images versus single image, it's kind of, I don't think so there is a clear answer there, right? Like, so I think we'll settle somewhere in between. At least that's what I feel, right? Like, single image is going to be too tall of an order for a super complex system. Too many images is a deployment problem. So like, it has to be, probably will settle for something in between for sure over time. Sammy did bring up how do we update a system while it's running? That is becoming super critical for specifically like 5.9 workloads in the data center environments. Independently resettable subsystems, right? So if you look at the picture that's on the screen, right? Like can we independently update it? Pause transactions while the updates are happening. So there's set of their ideas, there are thoughts, but like as Sammy mentioned, there's no standardization or rules around how we should go about solving some of the problems. So I think it's going to be super critical as we go into more of these distributed systems on how do we do updates, right? And it's going to be a pretty important dialogue in this forum.
I agree with everything said so far. I also think that mutability is an important piece here, because when you boot a machine today that's not completely heterogeneous, you have this sort of immutable starting point, and you build this chain of trust of all the components, and you know the provenance of them, and so on, right? It gets a lot more complicated when you have all these different components that are distributed now across the system. So I have to, maybe I did trust you when I started booting, right? But do I still trust you? Because I decided to run, I don't know, some bare metal workload or something, right? I didn't have full control over it. And so I think some of the challenges are also in how we establish these management sideband interfaces and make sure that we have that that provenance information and solve for some of these pieces as well.
Thanks, Sean. Right, like so on the same note, right, like via test, right, like this attestation is normally tied to the boot time measurements. Now we are runtime updating these things. Like so, what is our protocols for reattestation, right? There are ideas, but no standards, right? Like once you establish a TCB, you change the TCB. What does it mean, right? Like so, there are challenges that need to be a dialogue needs to be had in the forum.
Great. Let's see if we can have more questions from the audience. Looks like we have a pretty shy audience today. Come on.
Hi, I'm Eric from Pure Storage. I was wondering if you could maybe give some comments on heterogeneous computing and how the firmware would communicate maybe the power, differences in power usage over the different types of components that could be used in the system. Mainly thinking about like big little cores, but also could be like various different accelerators that you could maybe turn on or turn off, or various other resources.
You want to take her? Yeah. Yeah, that's a really good question. I think today, if you look at sustainability, I am also leading a sustainability efficiency metrics work stream. One of the problems that need to be reported, we are looking to report from the system is how much power is going to be consumed by the system. When you want to aggregate at a data center level, it's what is how much consumed, but you don't have the system level how much is going, but you don't have what is really used for compute versus non-compute. So that's a good question. Currently, we don't have the complete interfaces defined to say like, hey, what is that SSD is consuming? Maybe what is this DIMM is consuming? What is this VR is consuming? What is the fan is consuming? That type of information is not available. So we need to work to kind of define the metrics, at least interfaces. And we need to start looking and enabling it so that we can really go and say like, when I say ideal power, who's really consuming what there, right? And if I'm saying, I don't know, 50% load, what is that, who's consuming what? So that we can say which is really going to compute versus non-compute. It's not there. There are pieces, but not fully there.
Another comment, unless Vishal, you want to say something? No, please go ahead. So I would just add that look at the world we're in. We're heading in with chiplets, right? So part of the heterogeneous future, I think, is that you're going to have people wanting to mix and match designs from different vendors, right, and package them. And I think one of the things, this is further out, but since we're looking to the future, I think one of the interesting challenges we're going to have is that we're now very thermal constrained, very power constrained in these packages, and we want to have, I think, standardized mechanisms for reporting, not just telemetry, but also apportioning budgets. How much power, how much, what's the thermal budget for this particular package with all these interesting widgets that I'm now integrating, and that I need to update, I need to do all this stuff, right? But in these sideband sort of communication channels, I also need to say, well, here's how much power budget I have for the whole thing, and here's how much you get, right? And you might be a component that comes from some third party that I've integrated. So I think there's some very interesting challenges there as well.
Okay, so I think I'm actually asked earlier that we need to finish at 5. So with the 3 minutes left, I have the wrap-up question. In your opinion, the guest opinion, what role OSF, this particular project, should play in this heterogeneous compute environment?
I think the OSF can play an important role, right? First is like we need to identify what are the areas we want to attack, the areas with common themes. Standardization is going to be a key theme on how we specifically, like, what are the standards and, like, at least in OCP we can come up with. so we can have consistent interfaces versus like, every system having a different interface. So I think that is going to be a key part, like, once we go through, like, what are the common themes, how we can standardize some of them. A par one was a good one for that we just chatted.
I think my probably personal opinion is we have OSF, we have a hardware management, we have security teams. All those are kind of playing in the firmware area. We need to probably talk, and as a holistic system, where are the gaps and who's really covering what, right? Currently, like, there's a lot of things on out-of-band updates going on, but really, like, in-band, are they really in sync? In the security side, are they in sync? I think we need to have maybe a common talk and come up with a division of labor and decide what we want to do.
Yeah, I agree, and I think my own personal perspective, I'm a big proponent of UEFI and Tiana Core and EDK2 as firmware technologies. I think there's a lot of potential there to leverage these projects in heterogeneous systems, but we need to do more to add the right interfaces and the right management capabilities to these projects, right? We have this overarching umbrella in OSF, but I think there's a lot more we can do there to kind of set the stage for these interfaces to be created that we need.
Thanks. Yeah, I agree with the Sami. So right now in OSP, there are lots of the project. So the open system firmware need to do more cooperation with our other sub-project, security, hardware management, yeah, kind of things. Another one is, at least it's a community, so we are looking for the ideas from each of you. You can submit your ideas. Maybe we can do some incubation together to create more work streams, make things better, yeah. Contributing more on the heterogeneous computing, yeah.
Yeah, if you look at some of the other projects, right, they do have the sub-work streams focusing on particular areas, and I think we agree here that we do have a lot of potential areas to look into, and so in this project we probably should pick a few of the most important pieces to start and form some of the work streams. And you have Nill and Sami here as the lead, so you can shoot them the email, can copy me, so I can keep them honest. But anyways, I think we probably have a lot of work to do, so we need participations, right? So if you have ideas, if you think certain areas are the more important area to focus on, let them know. And then the OSF project could be very successful, leading the community into this environment for heterogeneous computing. So with that, I think our time is almost finished. I think we are the last one. Yeah, so we are 1 minute over. But I think we are here. Some of us are going to be around here outside the door maybe. If you have questions, you're welcome to come by. Thanks very much.